In this video, we're going to cover using 3D printed molds to stamp and form metal. What's going on, everyone? Today I want to cover a process that I've been working on here recently, using 3D printed parts to stamp and form metal to create a completely different type of shape than I would normally be able to create with other types of setups, at least not with significant amounts of work or tooling having to be created to do something similar. At this point, everybody's familiar with 3D printing. It's by no means the new thing. It's widely available. It's very affordable now, but it's still underutilized for the power and potential it really has if you just get to work and start thinking about the infinite possibilities that the application can have. I use 3D printed parts daily, either for fixturing for lasers, parts checking, alignment jigs, prototyping, all kinds of uses that are very specific to an application where you can make a low cost, immediately available tool to just get a job done without having to go through the programming of creating and then milling a part out of metal, for example. And this new process kind of fits right into that idea. Now, if you're not familiar with my channel, most of the things that I do are focused around scaled down versions of off-road vehicles. And I wanted to create some sheet metal panels that looked similar to how panels are created in the full-size world. And those are often being made with something called a bead roller, which can be run around a piece of sheet metal and it will inset a panel or an area of a panel. And this can add strength and style. There's a number of different reasons that it could be used. But small bead rollers are not necessarily something that's available in the scale of the parts that I'm creating. And even if they were, I don't know that I have a steady enough hand to make a scale version of that. So the next best thing to me was to create a tool to make this shape that I was looking for. And being that 3D printing is so powerful and easy, this seemed like the perfect application to employ it. So I decided to do some experimenting and create multiple different designs to take and make molds to stamp sheet metal. And in this video, I want to walk you through both an example of how I create the molds and the actual process of stamping the metal in one of these molds. I'm going to walk you through a very simplified and basic mold design in Autodesk Fusion 360. This is a free to download program that is very powerful, tons of tutorials and things like that. If you've never done CAD, this could be a great opportunity to learn. I'm not going to try and teach how to use Fusion 360, but I'm going to teach you the basics of what I have found to work for this process that I've been working on. Trying to learn CAD can be a little overwhelming at first, but if you have the desire to 3D print and you don't know CAD yet, you can really unlock the potentials of your tool if you learn CAD. It takes that somewhat useful 3D printer that you have and turns it into one of the most useful things that you can have around the house. So I'm gonna fire up Fusion 360 and we're gonna walk through these steps. So we have a new Fusion 360 file open now. We're just gonna go through the basic steps of what I do when I've been going through this process at this point. The actual part that we're going to stamp is something that I designed earlier and is much more complex than what we're actually going to design here. But let's start out by just opening a new sketch. So this is 50 millimeters by 50 millimeters. And we're gonna start off by just extruding that up by 2 millimeters. The molds that I've been designing so far have not been overly thick, and I'm just 3D printing them out of PLA. It doesn't take any fancy materials or anything like that. Regular PLA has been working just fine. And with the overall mold thicknesses only being in the 2 to 3 millimeter range, it doesn't take a lot of strength to get this process done. So for this example, this 50 millimeter square shape, that would be what our end panel would actually be. I'm just creating the outside edge for now. Now, after I've created that, I'm actually gonna go back in and create what will kind of be an outside border or like a skirt for it. And I'll show you why I'm doing this. So we're gonna create a square around the outside. This one's 70 by 70, so that gives us 10 millimeters on each side of this. Now in that also, I'm gonna put 2 circles, one in each corner. And we're gonna make these circles 3.1 millimeters so that they're an easy pass-through hole for a 3mm screw. And these screws are going to be our alignment pins. And the alignment pins are going to allow us to put the two molds together and keep them properly aligned. When you have a more intricate mold, it's going to be something more important. But either way, I found that a couple of alignment pins is a nice thing to add. So we've added that outside skirt. We're gonna extrude this up by 1mm. So now we have the inside square, which would be our total shape, and then the outside, which just kind of gives us that border and those pin spots to allow us to keep everything aligned properly. Now on that inside shape, this is where we're going to add another shape, and this would be kind of what our inset would be. Now for this one, let's just say we're gonna have a raised or an indented circle in the middle of it. And we're gonna draw that and then just say it's a 30mm diameter. And again, we're going to extrude that up by 1mm as well. Now, you probably can make these steps more drastic if you like. At this point, I've been pretty conservative with the distance. I've really been trying to stretch the material, just because the more you try and stretch it, the more it'll want to, crack or fracture or just possibly damage the actual 3D printed mold. Granted, you could do higher infill rates, things like that, to make these molds more durable, but that's all just going to be the experimentation, the materials you're using, the hardness. There's a ton of different factors that could play into that. But for this example, we're going to keep things pretty high level. So now we have the basics of the first half of our mold. Now there's some other important things that I do like to add. One, I do try and avoid these sharp corners. So on our main panel, I'm going to add just a few millimeters of a radius to each corner of that, just so that there isn't these sharp points in the mold to cause points where you'll have super high stress in the metal, which could make tearing much more possible. So I'm selecting that, and I'm going to make those a 3mm radius. Nothing extreme, nothing too much to worry about. I'm not going to worry about the outside edge of this mold because there's nothing actually going to be folding over that. Now, after I've taken off those hard points, now we're going to add a chamfer everywhere. And this is just going to be a 45-degree chamfer, and that's going to allow the metal to not have to do an abrupt step, again, creating a sharp point. Just like we tried to eliminate the sharp points by putting a fillet on each corner of our main square, this is doing something similar, trying to make it a more gradual and easy path for the metal to take. So since we did a 1mm step on each area, we're just gonna do a 1mm chamfer everywhere, and that will give us a 45-degree chamfer. And that is basically how you make one side of the mold. Now, to create the other side of the mold, in Fusion 360, I'm gonna take and just create an offset plane above the shapes that I just created, just so that I can easily sketch over top of them. So I've created an offset plane. Now I'm going to create a sketch on that plane. Now I could go in and just kind of start drawing shapes roughly over the top of the shapes that I created earlier, and then dimensioning from each of them. So like if I was to grab this outside edge of this new sketch, go into the tallest portion of the edge, and just add a 1mm offset. This is something that you can easily do, especially when the shapes are more, there's a lot of movement to them. For my instance here, I do know the dimensions. It was just a 50mm square, so I could just do a 52mm square all the way around. But this is a practice that I more commonly have been using when I'm using much more detailed shapes. Now you'll see that at this point, the outside edge of this new shape that I'm sketching is lying right around the edge of that chamfer, but we'll get to the details of that before too long. Now in this sketch here, I'm gonna go in and just fillet these corners here. Now we're gonna have a 4mm fillet at this case. I'm gonna extrude this shape up by 2mm. Now that offset plane I created, I could have made that further away to try and allow me easier views at these things. And there's other tricks you can do with turning things off and on and all of that. But at the same point, this is not a very detailed or difficult part to sketch. So I'm not really gonna worry about that. To make the negative space for the indent of the circle on our original mold, we have to rotate around to the bottom side and create a new sketch on the, what will be the bottom side of the top mold, we'll call it. Now we drew that as a 30mm circle the first time, so it's gonna be a 32mm diameter now. And then we're going to need to cut that up by 1mm. And then lastly, we need to mimic the outside shape of our mold in total. Now this one we don't have to offset, we're just going to make it the exact same size as our first half of the mold. And then we're also going to make sure that we include those alignment pinholes. We're also going to make sure that they're the same size at 3.1mm. So we're going to do a two-sided extrusion at this point. We're going down by 1mm and up by 2mm. That way it matches the highest point that we have on the other half of the mold. Now the last step that we have is we actually need to match the chamfers that we had on the first half. So we're going to go in and add a 1mm chamfer to everything. That's all it takes for this particular design. But there is one other thing that I want to do, and that's kind of show you how I go through the process of checking that the mold design is correct. So I'm going to select and actually move this top mold half down much closer to the bottom half of the mold. So I've got the two halves of the mold very close to each other at this point. Then in Fusion 360, we're going to go to section analysis. This will allow us to create cross sections of this mold. We're going to select one face, and then we're going to simply take and start dragging this view back. And we're just going to try and make sure that the space between the top and bottom mold stays fairly consistent. There may be a little bit of variation in areas where there's slopes and curvatures and things like that. But in general, we'll find that these should be pretty close to parallel. And in this case, kind of just walking through this design, we'll see that everything looks pretty good. Now this is a very simple mold, so this should obviously be the case. Now you can see in this area, once we stop, it looks like we have a very large gap, but it's just because we're looking at a very specific cut where we've got this large vertical difference. It's not actually a problem though. And if you wanted to double check that that was actually the case, you could just select another plane and start sectioning through it in another direction just to make sure that everything looks good in that view as well. So that gives you a very broad overview of how the design of these molds is done. But now we get to the good part, and that's actually stamping some metal. Now for this example, I'm going to be using 0.025 inch thick annealed aluminum or dead soft aluminum. You can find this at places like McMaster Car or possibly your local metal supplier. Ask around, search on the internet. There's a number of places that you can find this. And the reason that I found that to be the best material for me is that it gives me some thickness to work with, but it's very malleable and forms well for this type of a process. If you use a thinner aluminum, like you can find at craft stores or things like that, then it also forms very well, but it is thin and you really want to watch any of those sharp angles where you get some pressure points. You could possibly tear it. And also, if you're using a thinner aluminum, you'll want to modify the gaps that you use in CAD when you're designing these molds. Again, I used a 1mm offset for most of these areas because that's fairly close to the material that I'm using here. So that was the reason that I used 1mm. So I've already cut a piece of aluminum that matches generally the shape of the mold that we're going to be using. Now this is obviously a different mold than the one we just showed the CAD example of, but this is a piece that I actually plan to use in an ongoing project. I've already created one that looks just like this, except it's a mirrored version, but used it on one side of the vehicle. Now I need one that matches, but for the other side. So I cut the piece generally to fit just by taking the mold, putting it over top, tracing it with a Sharpie, and then cutting it out with a piece of tin snips. I also took, when I laid it over there, and marked the alignment pinhole locations and then drilled those out. Being that I'm using a 3mm screw, a 1/8 inch drill bit worked well for my alignment pin locations. But once we've got to that stage, now we can take and lay the aluminum in between the first half of the mold Then we're gonna take our second half of the mold and lay it over as well. Next, I'm gonna take a couple of pieces of 3mm hardware and bolt through some of these alignment pins. Now, I'm not actually gonna use all of these alignment pins that I put in. I'm just gonna use a couple of the top corners. It's not gonna really try and run around on you that much. I just want it to stay generally in the location that I'm interested in. My alignment pinhole locations are not symmetric, so there's no chance of me actually messing up the alignment of my mold, but in your case, it may be. Just make sure that you double check that. Now, something else to know about these alignment pins that I have. Obviously, these are not flush, they're sticking out. Now, depending on the method that you decide to use for pressing these panels together, this could be an issue. If, for example, you're trying to put this into a vise, having these things sticking out is not going to work. So in that case, you may want to print your mold much thicker and have pins that are internal to each other, and that could then, that creates longer prints and a lot of other issues. For me, I have tried a number of methods for actually stamping these molds together, but I found one that is very inexpensive, very easy, and I'm sure that you have everything you need around the house. In this instance, we're going to grab my block of wood. This is what I use for a drill block. When I'm working here in the studio, I don't want to drill into my table or work mat. I put whatever I'm working on top of this block of wood and then drill into it. But what I'm gonna do is take, and we're just gonna use our mold on top of this block of wood, and then we're gonna use a hammer. And this is a funny little short hammer, but it's really all that we need. I've found that this works really well, just as well or better than the vise method that I was using. And all we're going to do is we're gonna take and beat this mold together. Not all that hard. We're just going to take and constantly beat around all around this mold. We're gonna try and be fairly consistent with not being too light or too heavy in different areas. And once you've done this a few times, you're gonna be able to hear or feel when the mold is getting pressed together. You don't get that same feeling as when you first start. It's a little bit springy right now because you've got the gaps and the molds and it all kind of moves around. But once you start tapping, it all starts getting pushed together and becomes much more solid. So I'm gonna start going around and just tapping through this whole thing. And in the end, we're gonna open this up and you'll see the panel that we're left with. All right, we're gonna open this mold back up and see how it looks. Now, if we're too light in an area or anything like that, we can easily put it back in the mold. Since we have our alignment pins, we'll know exactly where it needs to be. Turned out perfect. This stamping method just really transfers everything over incredibly well. Almost too well, depending on maybe some of your print settings. For example, in this one, I can even see the travel of my actual 3D printer print head. So if you were to say smooth one of these, like PLA smoothing or ABS smoothing, depending on whatever method you want to use, or you just have a really well and fine-tuned 3D printer, maybe you won't even have those. But this just works so well and transfers the design over so well that everything really shows through. So the better quality of your print, the better quality of your stamp. So on this part here, I actually plan to trim this whole piece out, and this outside skirt will just get thrown away. Honestly, this method is just very impressive to me and creates parts that I really like the look of and enjoy. One other thing that I incorporated into this particular mold is this line here. Now this line is not for looks. This line is an area where I actually need to put a bend in this final part to create an inner fender and then the area that kicks up that creates the passenger compartment. Just something that I knew that I needed a bend in the final product. I wanted a nice straight line in it, especially since I'll have these inset areas. I wouldn't be able to put this piece of sheet metal into my sheet metal brake without actually, damaging or undoing the work that I just did. So I figured I'll just put this line in my stamp and then I've got the perfect line put in there. It just takes a little bit of thought ahead of time and you can create something that has all kinds of details that honestly, I don't think that there's probably very few craftsmen who would be able to do this with such precision as what we just did with some very simple tools. So now I need to get this piece all cut out, trimmed, and then sanded and filed to make it fit my project. So there you have my broad overview of this process that I've been working on, just taking these simple 3D printed molds and transferring it to a different material completely. So, you know, a lot of us can get kind of numb to the fact that 3D printing can create shapes so easily. And now we look at 3D printed parts just like, oh, it's another 3D printed part. But sometimes, you know, the actual feel or look of a metal part can be so much more impressive. But in reality, it can be almost just as easy as creating the 3D printed part itself. So hopefully some of you guys find this helpful or can find an application where this would apply to something that you can do. If you have any questions about the process, feel free to drop them below. I'll answer anything that I can. This process, I'm positive, can be pushed much further than what I'm showing in this video. This is a very simple example of something that can be easily accomplished. Taking this and running with it and creating things that are much more intricate or ornate or have a lot more stretch to it, or using different materials and creating exotic shapes, or maybe pre-cutting the sheet and using that to create a louvered effect, or who knows? The possibilities are truly endless with both 3D printing and metalwork. So by all means, if you can take and run with this and go much further than I can, please drop me a link to wherever your work is. I'd absolutely love to look at it. This is a process I definitely hope to grow into and learn more about, hopefully come up with things that I can use this with that are a little bit further yet than even I can think of at this point. If you have an idea of something that may push this even further, drop that below as well. Definitely something that I'd be interested in hearing what your thoughts are. Thanks for watching, guys. I appreciate it. Hit the like button before you leave. Subscribe if you're not already. Hit the notification bell so you see the videos as soon as they get uploaded. Once again, thanks for watching, and we'll see you on the next one.